Before us here is a question on limits. We are asked to evaluate limits as x tends to 0 of ln of 1 minus x squared minus ln 1 minus x all over what? 2x. Alright. The question seems complicated, but it's very simple if you understand the basic approach or the simple approach towards it. Now let me remind you of this. Whenever you come across ln is otherwise known as what? Logarithm what? Function. The log of what? Number to base e. That is what ln what stands for. It means the natural log to base e. So it means that what this is also a log, this is also a log. Now, before we evaluate this limit, we have to do justice to this numerator. So doing that, we have to apply the laws of logarithm. Let us combine this and this together. Remember in our log, the law that says if I have log x to base a minus log y to base what? L, means that we're having a common base, and this is separated by what? Minus. So it's going to give us this, which is log of x over what? Y. Remember, we're going to have a common base. So the same thing is going to happen here. So we're going to combine this together. So meaning that what? In this numerator, I am going to have my limits as s tends to 0 of, we have 1 minus s squared all over 1 minus x. Then it's carrying what? Ln. So what does that mean? This thing now is not the log now, representing the log. But this one is different from this. Because this one is a natural, this ln is a natural logarithm. The one that has what? Base e. While this one is a common logarithm. It can take any number. So then all over your 2x here. All over 2x. Okay. Now let's go further to this numerator. So we are going to simplify. What this means in algebra? It means that this app here, whenever we are having 1 minus s squared, we are talking about difference of two squares, which means I am going to have my become limit of this s tends to 0 now. We are expressing further. So app, we are going to have a 1. When we have this kind of thing in algebra, we're going to have 1 minus x. Then take 1 plus x. We bring this here, which is 1 minus x. Remember, this one is this, and everything over 2x. Okay, so we are going further. So in this case, 1 minus x is here, and 1 minus x is up here. So this can subtract this. That's gone. Now, we have 1 plus x. Remember, that is ln. Do not forget. Sorry, there is ln here. It's carrying ln. Alright, sorry for that mistake. Apologies. So here it's carrying our ln. So we now have it what? We are now left with what? Ln 1 plus x all over 2x now. So mean that what? Our limit now is now what? X tends to 0. We're having ln 1 plus x all over what? 2x. Okay. This 2 here, 1 over 2 here, can be factored out. So which will now give us equal to something like this. 1 over 2. We have a limit s tends to 0 of ln 1 plus x all over x. I want you to recall one of the laws of limits, standard limits for some functions. So we have this type of this. Whenever you have something like this, we have a limit as s tends to 0 of ln of this 1 plus x all over x. The whole of this is equal to 1. Yes, the whole of this is what? 1. So try and recall all those basic logs of a limit. So that means that what? Evaluating the whole of this now is going to give me 1. That means the limiting function of this ln of what? 1 plus x over s. So the whole of this is what? 1. Therefore, you now give me what? 1 times 1. 1 over 2 times 1 rather. So this 1 over 2 is already outside. Then 1 times 1 over 2 is equal to 1 over 2. That is the answer to this question. So we're looking at the question from the beginning. Seems kind of difficult, but at the end of the day, you evaluate it and you deserve the answer. If you find this class very interesting, please do not forget to share this video and also subscribe to our YouTube channel, Physics and Mathematics Lovers. Bye.